Hello, welcome to my YouTube channel Prakash Coaching Classes. Today we are going to continue the electricity chapter which we have started. So today in this chapter we are going to discuss the resistance combination of series and parallel. So next let's start with the first topic, resistance in series. Resistance in series combination means this type of diagram. In this, the two resistance are connected in series. I have taken an example, simple example of two resistance in series. You can take 3, 4, many more, and number of resistance. So let's try to understand how the combination works. What is the resultant equivalent resistance of the combination of the resistance, and what are the important points to know about the combination of resistance in series. First, this is the example, this is the circuit diagram which I have taken. There is a voltage source, there are two resistance, and there is a closed circuit. The V1 represents the voltage across the R1 resistance, V2 represents the voltage across the R2 resistance. Again, the voltage combination is V1, V equals to V1 plus V2. Using Ohm's law, V equals to IR. Substituting this value I, which is common across the resistance, as you can see with the circuit diagram, IR equivalent, R EQ equals to equivalent resistance of the circuit. IR1 plus IR2. Then solving this equation, we get R equivalent equals to R1 plus R2. If we have more resistance, suppose 4 or 5 combination of resistance, it will be continued. This is what the equivalent resistance formula is in the series combination. Coming on to the important points. First point, in series current remains the same in each resistor. As you can see in the circuit diagram, the resistance, the current across each resistance remains same. Second point, in series the net resistance is the algebraic sum of the individual resistance. This we have already discussed. Third point, in series the voltage across each resistance is different. As you can see, the voltage across R1 and R2 is V1 and V2. This will not be same. Now resistance in parallel. So we are going to discuss the next combination of the series of the resistances. So this is the parallel combination. You can see the parallel combination. The voltage across this remains the same across each resistor, and the current is varies. Suppose we have considered I current is flowing in the clockwise direction. The current splits across each resistance I1 as I1 and R2 across R1 and R2 resistances. Now we see the I net current is equals to the current in the individual resistance, which is I1 and I2. Applying Ohm's law and substituting this value, we get the equivalent resistance as 1 upon R equivalent equals to 1 upon R1 plus 1 upon R2. So some important points in the which we need to remember while solving the numericals in the parallel combination of the resistances. First one, in parallel the voltage remains same in each resistors. As you can see, the voltage across each resistance is same and does not vary. Second point, in parallel the current across each resistance is different. As you can see, the current across each resistance is different. Now let's apply this into the numerical and try to understand how it works in the series and parallel combination of the resistance. Now let's understand the combination of series and parallel of resistance with the help of this example. Here we have 1 volt 12 volt battery, R1, R2, R3, R4, I5 in resistances in which R1 and R2 are combined in the series parallel combination, while and R3, R4, R5 also combined in a separate parallel combination, and the resultant of these two are combined in series combination. We have one ammeter which is there to measure the current flowing through the circuit. So we need to calculate the equivalent resistance I and R equivalent, the resultant equivalent resistance. First we will calculate equivalent resistance, and using Ohm's law we will calculate I equivalent. This is the process which we are going to follow to calculate this problem. First, calculating R equivalent, there are two parts. First, we need to calculate the R equivalent of R1 and R2 separately and R3, R4, R5 separately. So R dash is the equivalent resistance of the combination of the two resistance R1 and R2. Similarly, R double dash is the combination of the R3, R4 and R5 resistances. Calculating the value, we get 8 and 10, and these two resistances equivalent are combined in the series form. So we have series combination, which we get 18 ohm. Again, applying Ohm's law, we are getting the I equivalent. So hope this example makes you feel how to use series and combination resistances in series and parallel combinations. Now, heating effect. Heating effect, heat produced when an electric appliance uses electricity, it emits heat. But this heat can be utilized in various practical examples in our day-to-day life. So we are going to discuss one by one them. So first of all, what is heat produced? It is the H equals to I square RT. This implies that heat produced is directly proportional to the square of the electricity flowing through the appliances, and it is directly proportional to the resistance of the conductor, and 3, the time duration during which the heat is flown. So this we get I square RT. This is basically called Joule's law of heating, and it has various examples in our day-to-day life. So the applications are electric iron. As you all know, we have in our household, we use electric iron to iron our clothes. So that works on the principle. Electric geyser is another example, oven is another example, and electric bulb is one of the most widely used example in our household life. There is a tungsten filament which is very high melting point of around 3380 degrees centigrade, so it generally don't burn and it emits light. Third is electric fuse, which nowadays is replaced by the MCB. In earlier days we use electric fuse. Next topic is electric power. Electric power is basically power, a voltage into the current VI, and its SI unit is watt, which is represented by W, and 1 kilowatt, which is generalized power unit, is nothing but 3.6 into 10 to the power 6 joules. Thank you for watching this video. Do like, subscribe and share the video.